Howdy folks, welcome to the first YouTube Direct lesson. I can find something that's already made. I'm not going to make these, but I couldn't find one that I liked on this, so here we go. Okay, so today's topic, which picks up after our last one, because I'm sure you've got done 4.3, is fractional exponents and radicals. So before we get into that, we've got to review our rules, which I know you already know. If we're multiplying two bases that are the same, what do? Of course, we add the exponents. So for example, if I had 8 to the 5 times 8 to the 6, of course we just 5 plus 6 and get 8 to 11. I recommend watch this and write stuff down after, or pause it lots, whatever works for you. So that's all fine and good, but what if we have something with fractions in it? Well, the rules are the same. My base is the same, so I just have to add the exponents. So 1/2 plus 1/2, of course, oops, I missed the 1 there, would be 1. But do you need to write that 1 down? No. I'm just doing that to show you. Of course, you know that 1/2 plus 1/2 is equal to 1. But what does 7 to the 1/2 mean? Okay. Well, I want to switch this into a radical because this is the whole thing. We're going to have to take something with an exponent and a fraction and switch it to a radical. So this 1/2 means it's actually saying the square root of 7. Well, that's a nice looking radical, isn't it? So again, that 2 here means square. And we never write the 2 in our index part, which I'm going to call something else right away, because everything is square root, unless it says something else. For example, my next example here, I've got 8 to the 1/3. Well, what I like to think of is whatever I have in the denominator here is that the denumber in denominator goes in denotch, which is where I've got the 2 on the 7 there. And it's not the most mathy thing in the planet, but I like it because the 3 goes in denotch because it's in the denominator. I wish I made that up, but I didn't. A guy, I read that in a textbook from Saskatoon, made that, and I like it. So what we're going to do is we're going to write as a radical here. So if I had, 11 to the 1/9, the 9 goes denotch, and it's root 11. Kind of like that. So our general rule is if I have x to the 1 over n, the n goes into notch, and whatever x is goes underneath the radical. So for example, if I have 64 to the 1/2, well, that's just saying square root of 64, which you know is, yeah, it's 8. Oops, wrong way. Or let's see, if we're taking the cube root, or because it's a 3 there, and of course 3 is cube, of negative 27. Wait a minute, we can't take the square root of a negative number. This is not a square root. It is a cube root. What number times itself 3 times gives us negative 27? Well, that's negative 3. And the numbers get bigger. 256 to the 1/8. Holy cow. Well, 8 goes into notch, or the index, which is the proper word. What number times itself 8 times? 8 times gives you 256. Well, if it's 8 times, it's got to be pretty small. Probably an even number. Yeah, 2. Don't get intimidated by fractions. If I'm saying 25 over 49 to the 1/2, of course 1/2 means square root. Just rewrite it as square root of 25 over square root of 49. Well, that's a snap. That's 5 over 7. Good. Where it does get a bit harder, however, is if we have a decimal exponent. Okay, 16 to the 0.5. Okay, 0.5. We know that's 1/2. That's not bad. Oh, we know that's square root of 16. That's 4. No problem. However, it does get a little bit harder. I've got 243 to the 0.2. So, oops. Oh, well, I've got it already. That's like basically over 1. What in the world do we do to get rid of decimals in a fraction? Well, that's right. We multiply it by 10 over 10 because, of course, any number over itself is equal to 1, which would give us 2 over 10, which reduces, of course, to 1 over 5. So that is 243 to the 1/5. Oh, you're saying that 1/5 goes in exponent? Absolutely. So that means if 5 goes into notch, what number times itself 3 times gives us 243? You got it. 3. Okay, next page. Okay, now I want to go the other way. I want to write as a radical and put it in exponent form. So if I've got the square root of 2 to the 7th, and I don't know if the question would have a 2 in the notch, probably not. But I've written it in there just a reminder because what goes in our denominator comes from the notch, which is the index. So we'd have 2 to the 7 over 2. Another one here, cube root of 18 squared. Again, not figuring it out. Don't want to know what it is. It's just switch to exponent form. That's all this question is. So what's in the notch? Or I'm sorry, in the denominator? Well, that's the 3. And 18 squared, so 2 over 3. Okay. Another one here. Fourth root of 25 to 25 cubed. And the notch is 4, so that's the denominator, 3/4. That's it. Yeah. Okay. Okay. Word problem here. I use the formula of w to the m 0.5. Oop, I forgot to type in the exponent, m to the 3/2, where w is the weight gained in kilograms and m is the mass of ice cream I eat to determine how much weight I gain if I eat A, 4 kilograms and B, 16 kilograms of ice cream. I thought I would write a question that was my life. So here, let me scroll that back down here. So with these kinds of word problems, write down the formula and then fill it in. So of course the formula that is given is w is equal to 0.5 m to the 3/2. So the first one, m is the mass of ice cream that I had, so m must be 4, so I better put in 4 for m. Okay, 3/2. I know I can half means square root, so I can square root 4. Of course, bedmas and all that stuff, exponents first and all that stuff. So square root of 4, which is 2. 2 cubed, 8, times that by a half. Well, I guess I gained 4 kilograms. Okay, another one here. If I eat 16 kilograms, again, start with a formula. Put in 16 for m. And 16 square root of 16 is 4 cubed, which is 64, which gives us 32. Well, that doesn't seem very proportional, but basically, if you're sitting around eating 16 kilograms of ice cream, what I'm saying is you're getting fat. And we all know I write my own material. Okay, so in general form, if we have x to the m over n, like I keep talking about the notch, n goes into notch and m can go underneath the radical, or you can write it with n in the notch and m is out in a bracket, and it's all the same. And the assignment that goes along with this is on page 227, 3, 4, 5, 6, 7 ACE, 8 ACE, 12, 10 to 12 ACE. Oh, there's more here. 13, 15, 17, 18, 19, and 21. Great. Hope you had fun. More to come. Bye now.